Little pet project I've been making since the start of this year is kind of ready, so I thought I'd make a little demonstration. It's a Mastodon client that works on the Apple IIc. Over the serial port, of course, because there's no network on this machine. So there is a Raspberry plugged on the other end of the serial cable, and it is tasked with all the network requests and everything. Of course, it's a little bit slow because it runs at 9.6 kilobits per second. I couldn't make it work faster, but then again I've seen that not a lot of people manage to do that. So the interface is of course in text mode, and it loads the messages 10 by 10. You can scroll in the messages. Most of the basic functionality is implemented. For example, you can favorite a tooth with the F key. You can write. It starts another program because there's a little bit of code. Not everything would fit in a single program with enough RAM available for the data. So this is the composer. I'm quite happy about it. I've made a multi-line editor from scratch because nothing exists to do that on the Apple IIc by default. It's fully editable. You can scroll in it. You can do about everything that you need to do without having to rewrite the whole message. Then you can send it. I send it unlisted in order to avoid having too much text showing. And now we're reloading the main program, and we should be going back where we were. So that's the timeline, the home timeline. You can open a message to see replies it has. You can go back. You can search. Every list that displays is a new list that stacks on top of the previous one. And of course, we unload the data for the previous ones before loading a new one, so that we keep a little bit of memory for the data. If you scroll a lot, you're reaching the end of the loaded list, and we load more. As you can see in the lower left corner, I'm tracking the memory usage quite precisely to make sure that we don't run out of RAM. I can also show you the image viewing program, but it's probably going to be disappointing because the Raspberry does on-the-fly conversion from PNG or JPEG to HDR, and the results are not always very legible, especially on the green monitor. On the emulator with a color screen, it's a little bit easier to see the image behind the dots, but well, let's check. Apparently this is supposed to be a map of flights. Well, yeah, we can guess it's a map, but we don't see the flights. There's also a profile view. So to interact with a message, it has to be the first one on the list. That was the most logical thing I thought of. So let's hit P to check my profile. So this is me. We can see my profile images if we want to. Yeah, that would be me. I think I've shown about everything the Mastodon client can do. So you can write, you can reply, you can scroll your timelines, search. Maybe I show a little bit how it works behind the scenes with some code examples. I do hope that it's going to interest people, and maybe the FusionNet people will want to port it to FusionNet Wi-Fi. I don't have that device, so I can't do it, but I'd love to see it work faster than using this very slow serial link. Thanks for watching. So that's the main window I used when developing for the Apple IIc. On the left pane you can see the serial proxy running. Of course it's running on a virtual serial port, which is then read and written to by a serial to network proxy, and the MAME emulator uses that. It allows for faster development than having to upload to the Apple IIc each time. So you're going to see exactly what you saw on the Apple IIc earlier. This is not really what I want to show you right now. Okay. So what's in there? There are the binaries. As you can see, I'm building both for the Apple IIc and for Linux POSIX with GCC, which allows me to run my programs monitored by either GDB or Valgrind, making it much easier to see any memory bugs I could put in by mistake, because debugging on the Apple II is quite harder. So there are 5 programs. There's the first one, Mastodon, is the one you see at start with the logo asking you where you want to connect. and it's tasked with connecting you, and then passes an OAuth token to the main program, Mastodon, for command line interface. This one is the one having the timeline, search and notifications and all of that. Master write is the one that I've shown you earlier, where you can compose a message or reply to a message. It's also separated for RAM memory usage, minimizing memory usage. And then this one I didn't show you. It's a little configurator that allows me to ask the user whether he's on a US or French keyboard. This is used to convert char sets from UTF-8 to something the Apple II understands. And it allows me, as a French guy, to have accentuated characters in my timelines instead of having bullshit characters. And finally, master image is the one that displays images. So then there's the source, which are separated in API with the entities, status, account, notification, and CLI, which is the interface. So let's see, for example, the API.c file. So there we are. I'll show you the API get posts method. So it builds an URL, and then it gets a SERL, which is short for serial URL, and is inspired by the fact that my proxy mostly works with curl. And this I show you too. It lives in lib. It has a few methods. So the proxy connection, the new request starter. This is a helper method to free everything related to the request. A helper method to check if the response is okay, because I didn't want to copy paste everywhere, whether the pointer is null, whether the code is under 200 or over 300, everything like that. And then there are a few methods that allows you to read the response header. So this is the network response header, like HTTP code and content type. Receive data, which allows the proxy to send data by chunks of a length specified by the developer. You can also receive headers if you need to, but mostly I don't need to use that because the proxy handles cookies for me. Receive lines is a method to receive text data and making sure it ends at a new line. So it is useful for buffered input-output. I don't use it for the Mastodon client, but I use it for another soft. Then you can send data for uploading, like when you send a message, these are used. And those are helpers. Find line allows me to check whether there is a string in the response without having to download the full response. And it's, for example, used in the login process, where the HTML pages that the server sends back are like 30 or 40 kilobytes, and I don't need it to fetch all of it just to get one line. And this one asks the proxy to parse the JSON that's presented in the response and give it back to us in much easier to parse manner, as that is raw text separated by new lines. For example, here we open a request to the timeline endpoint, we check that the response is okay, and we get the JSON that we want using selector. So the selector depends on whether we are on a search, in which case we want the IDs in the statuses array. If we are in an account, we want just the IDs in the root array and everything like that. For example, if you look at let me remember. No, it's there. If you want status and replies, it's the API of Mastodon is quite annoying because it doesn't put the message you want replies to in the main array, so you have to get a specific endpoints for context, and then you have to parse the answer, which has two arrays, ancestors and descendants. So the JSON selector is quite complicated and quite annoying to implement, but I'm glad I don't have to do the parsing on the Apple II. So that's about it. I don't know what more to say. The CERL library itself relies on a simple serial API that I did because CC65, the compiler I use, doesn't have a very large serial API, mostly for size reasons, I suppose. So I've extended it a little bit to allow having a few more methods to help me, like for example put string, which outputs a buffer until it meets a null byte, or get string, which reads until it finds a new line character. There's also read, which reads as much as you wanted it to read. And of course there's write, which writes as much as you want it to write. On the other side, there's the server, which is in another directory, and which is kind of ugly. Let me tell you, but mostly what happens is in single methods, where you get a new request, then you get its headers optionally, and once you got the request, you execute it with curl, which means you get the answer. You can then send the header back to the Apple IIc, and then we're just going to sit there until the Apple IIc requests another page, and this allows us to keep the current response in memory and wait for commands. So it can be a send command to send the response data to the Apple IIc. It can be a find command, so we only send what the Apple IIc wants. It can be HGR. HGR is a shortcut to get an image, put it in a file descriptor, convert it to HGR format, and then send it back to the Apple IIc. It probably needs a little bit of refactoring, but it works quite okay as it is, so I'm happy with that. Yeah, and also when you're doing JSON, you can pass parameters. You can either ask the proxy to translate HTML to text, and you can ask the proxy to convert the jar set, which is something I didn't want to do on the Apple II. So, and then we have our binaries, 5 binaries as I was saying earlier, and as you can see the programs are quite large. The main program is 34 kilobytes large, and sadly most of them ship with duplicated statically linked code, but it fits on a single floppy, so that's what I wanted to achieve. And I'd rather have it like that than having a huge program with no room left at all for data. Because if we had to load messages one by one, it would be even more sluggish than it is already, and less optimal in my opinion. So here we are. Thank you for watching, and I hope you like it.